ओके, तो इलेक्ट्रोस्टैटिक्स चैप्टर में से हम लास्ट टाइम उन्हें यूज किए थे. लेट अस सी सम मोर एमसीक्यूज हियर इन दिस लेक्चर. I hope you can see the screen. So just read this question first. Radii of inner and outer spheres of a condenser are 9 centimeter and 10 centimeter respectively. Okay, तो एक कंडेंसर है जिसका इनर और आउटर रेडियस दिया हुआ है 9 centimeter and 10 centimeter respectively. If the dielectric constant of the medium between the two spheres is 6 and the charge on the inner sphere is given to be 18 into 10 raised to minus 9 coulomb, then the potential of inner sphere will be. Okay, so we want to find out the potential on the inner sphere. So yes, see here, this is the example of a spherical capacitor. Actually, we know that spherical capacitor actually consists of the two spheres. One is inner and the other one is outer, like this. So these are the two capacitors or two conductors which are like this, and the inner conductor is actually connected to a positive or negative charge like this. In this way, ये एक चार्ज की तरफ कनेक्टेड है और दूसरा जो कंडक्टर है तो वो भी कनेक्टेड होता है नेगेटिव चार्ज की तरफ, like this. So in short, there is a dielectric medium of some dielectric constant in between these two metallic spheres. Okay, तो अभी इस ऐसे टाइप के स्फेरिकल कैपेसिटर का जो कैपेसिटी है तो उसके लिए हमारे पास एक रेडीमेड फॉर्मूला है जो हमने लास्ट टाइम डिराइव भी किया था थ्योरी के अंदर, जो कि सिंपली 4 पाई एप्सिलॉन नॉट इनटू R1 R2 अपॉन R1 प्लस R2, ये फॉर्मूला होता है. और अगर वो डायरेक्ट कांस्टेंट k है तो यहाँ पे k भी आ जाएगा, नो डाउट. So this capacity of this spherical capacitor here can be found out in this way. Okay, so 4 pi epsilon का वैल्यू होता है वो हमको पता है ऑलरेडी, 1 upon 9 into 10 raised to 9 here. Okay, so this is 9 into 10 raised to 9 and this k is here going to be 6. बराबर है, ये जो डायरेक्ट्रिक कांस्टेंट दिया हुआ है यहाँ पे ये 6 है, तो यहाँ पे हम 6 डाल देंगे इधर, और R1 R2 और R1 प्लस R2 ये वैल्यूज हमको यहाँ पे रखने हैं. तो R1 का वैल्यू कितना है 9 और R2 is 10, but don't forget that they are in centimeter, so we have to convert them into meter. So it will be 9 into 10, so it will be 90, but we have to multiply it by 10 raised to minus 4 because both of them are in centimeter, right? And R1 plus R2 means it will be 9 plus 10, which is going to be 19, and that will be multiplied by simply 10 raised to minus 2 only. So here, and also that okay, so this will give us the capacity actually. So capacity will be actually यहाँ पे 9 1 जा 9 10 जा, तो ये तो कैंसिल हो गया, बाकी 60 upon 19 बचा, तो ये 60 upon 19 kept as it is, and that is to be multiplied with power of 10, which will be actually minus 4 plus 2 is minus 2, and minus 2 minus 9 becomes minus 11 actually. So this is going to be the capacity in farad. Okay, so once we get the capacity, we can just get the potential difference also. So potential difference between the two endpoints will actually be Q by C, right? Where Q is already given. Q is given to be 18 into 10 raised to minus 9 coulomb, right? And that is to be divided by C, where C is going to be 60 upon 19 into 10 raised to minus 11. Okay, so finally after solving this, we can just get this 19 in the numerator. So 19 into 18 upon 60 kept as it is. So here we can write it as 19 into 18 upon 60, and that is multiplied with 10 raised to 2 here. Yes, 10 raised to plus 2. So approximately, if you just multiply this 19 and 18 together, so 18 का square हुआ करता है 324, करेक्ट है? तो 324 के आसपास अगर इसको हम लिख देंगे आराम से, तो दिस इज 324 upon 60 and 10 raised to 2, which makes it double zeros. तो ये एक 0 0 कैंसिल हो जाएगा और हमको सिंपली मिलेगा 6 5 30 24 मतलब 6 4s and 0 as it is. तो 500 के आसपास आंसर आ रहा है. And the potential of outer sphere is not given actually. Outer sphere is Earth. That means the potential difference will be same as the potential of inner sphere only. Let us see the answer. Okay, हाँ नहीं बराबर तो है. Okay, yeah. Actually, the formula is here R1 R2 upon R1 minus R2. Okay, that is the only mistake we have done here. Yes, so actually minus sign should not plus sign should not be there. It should be minus here. So because of that, we can just have this changed slightly. So we can just have this R1 minus R2 here. So that अभी R1 minus R2 कितना होता है 10 minus 9, which comes out to be actually 1 only. So only 1 will be appear here. 19 के बदले 1 आने वाला है बस. तो यहाँ पे भी 1 आएगा सिर्फ. ये तो हो गया चलो कैपेसिटी जो कि 60 into 10 raised to minus 11 farad. So if you just put it here, then we can just get this 60 upon 1. ये 9 should not be there. Okay, so ये जो ऊपर जाएगा तो ये 19 भी नहीं रहेगा, यहाँ पे सिर्फ 1 रहेगा. तो 18 by 60 into 10 raised to 2 मतलब 1800 upon 60. 0 0 cancel, 180 upon 6 मतलब 30. करेक्ट है. 30 will be the correct answer. 30 volt. Okay. Only this minus sign has to be remembered here. ये minus sign होता है यहाँ पे. ठीक है. चलो ठीक है. So let us take this next question. Yes, energies in the capacitor and dissipated during the charging of capacitor bear a ratio of. देखो, energy is stored in capacitor and dissipated during charging of capacitor. मतलब चार्जिंग करने के लिए और स्टोर होने के लिए जो लगने वाला एनर्जी है वो तो सिंपली सेम ही होगा. So it will be 1:1, no doubt. An uncharged capacitor with a solid dielectric is connected to a similar air capacitor charged to the potential of V0. Okay, if the potential after sharing the charges becomes V, then the dielectric constant of dielectric must be. Yes, so this is also a simple question. See, we have already seen that if suppose uncharged capacitor and a charged capacitor, In general, we have seen that if suppose the two charged capacitors with the charges Q1 and or suppose that the first capacitor is charged with V1, second capacitor is charged with V2, and first capacitor has the capacity C1 and the second one has the capacity C2. If they are connected together in parallel like this, so ये capacitors अगर हमने इस तरह से connect किए parallel में, तो effective common potential difference between the two ends is given by the formula V is equal to C1 into V1 plus C2 into V2 upon C1 plus C2. If you remember, ये हमारे पास फॉर्मूला ऑलरेडी है. तो यहाँ पे फिर यहाँ पे जो कॉमन पोटेंशियल है वो तो भी दिया हुआ है, और अभी इनिशियल कंडीशंस के अंदर ही दिया हुआ है कि अनचार्ज कैपेसिटर, दैट मींस द फर्स्ट कैपेसिटर इज गोइंग टू बी अनचार्ज्ड, दैट मींस V1 इज गोइंग टू बी 0 हियर, राइट. एंड विद द सॉलिड डाइलेक्ट्रिक, तो इसका मतलब जो फर्स्ट कैपेसिटर जो है C1, its capacity must be actually K times of the capacity of the second one. That means we can just consider this second capacitor to be simply C, and the first capacitor will have its capacity to be K times of C. And if you just replace all these values here, so V1 is going to be 0, V2 is going to be V0, and C1 is going to be Kc, and C2 is going to be simply C. So it is become C1, which is Kc here, plus, sorry, V1 is going to be 0 here in this case, okay, plus C2 is going to be simply C, and V2 is going to be V0 here in this case, which is to be divided by C1 plus C2, where C1 is going to be Kc and C2 is simply C. तो अभी इसको अगर हम आगे सॉल्व करेंगे तो we want to express this V, नहीं, we want to express K in terms of V and V0. Okay, so K को अगर हम निकालेंगे ठीक से, तो यहाँ पे V as it is, V will be equal to 0 plus CV0, becomes CV0 only. And if we just take this C common from this, then we can get K plus 1 inside, and C will just get cancelled, and we'll be left with V is equal to V0 upon K plus 1, correct? Which means this K plus 1 is actually going to be V0 upon V, right? So K then must be equal to V0 upon V minus 1, means K should be actually equal to V0 minus V upon V simply. So this is to be the going to be the correct answer. So K, that is a dielectric constant, must be V0 minus V upon V, which is going to be at this third option here, V0 minus V upon V, which should be the correct one. Let us check. Okay, so third answer is correct. Correct. Yes, let us see the next question. Okay, the energy of 100 microfarad capacitor charged to 6 kilovolt could all be used to lift a 50 kilogram mass. What would be the greatest vertical height through which the mass could be raised? Okay, मतलब इसमें क्या है ना कि सिंपली हमको एनर्जी ऑफ कैपेसिटर और पोटेंशियल एनर्जी को इक्वेट करना है. मतलब कैपेसिटर का जो एनर्जी है वो यूज करके हमने उसको उससे एक मास 50 किलोग्राम का मास लिफ्ट किया अगेंस्ट ग्रेविटी. तो ऐसे केस में जो कैपेसिटर के अंदर चार्ज एनर्जी होगा हाफ CV स्क्वायर से जो निकाल सकते हैं, it should be equal to the energy required for raising the mass M through the height h. That means mgh will be the potential energy which is required for raising the mass of M through the height h here, which should be obtained from the capacitor, okay, which is going to be half CV square, where C is going to be 100 microfarad and V is going to be 6 kilovolt. So if we just have this as half into C which is 100 microfarad, that means it will be 10 raised to minus 4 farad, and V is going to be actually 6 kilovolt. तो किलो मतलब 10 raised to 3, तो ये बन गया 6000 वोल्ट. तो इसलिए 6000 वोल्ट और उसका स्क्वायर हमको करना है. and that is going to be equal to mass, which is 50, into gravity, which is 10, and h to be found out. So keep it as it is. So here we can just get this 1 by 2 multiplied with 10 raised to minus 4 into 6 का square बनता है 36, और 10 raised to 3 का square बन गया 10 raised to plus 6 here, which is going to be equal to 500 into h, right? So that this 2 just get cancelled with this 36, leaving behind 18 here. So it will be 18, and 10 raised to minus 4 into 10 raised to 6 becomes 10 raised to 2 here, which makes it 18 as 1800 here. And so this 1800 is going to be 500 into h, means h should be equal to 1800 upon 500. So that it comes out to be 18 by 5. And 18 by 5 is going to be 3.6 actually. So it should be 3.6 meter, which is there already in option number 2 here, which must be the correct one. Okay. So let us see the next here. What is the value of capacitor if the thin metallic plate is introduced between the two plates, parallel plates of area A and separated by distance D? Okay. What is the value of capacitance if a thin metallic plate, yes, is introduced between the two plates of area A and separated by distance D? But what is the thickness of that metallic plate? It's not given here. If it is thin metallic plate, then the capacity will not change at all. See, because एक सिंपल सी बात है कि अगर मान लो ये एक कैपेसिटर है, ये उसके दो प्लेट्स है, ठीक है, और इनके बीच में इनका कैपेसिटी सपोज C है, जो कि एक्चुअली हमको पता है C इज गोइंग टू बी इक्वल टू A एप्सिलॉन नॉट अपॉन D के बराबर हुआ करता है, ठीक है। अभी अगर हमने इसके बीच में एक थिन प्लेट डाल दिया इस तरह से, so it will be equivalent to two different capacitors. One is at the right side and the other one will be at the left side in this way. And by default, if suppose the distance between these is D, तो अभी यहाँ पे thin metallic plate दिया हुआ है. Thin का मतलब क्या होता है कि its thickness is very very small as compared to the distance between these two plates here. So the distance between the plates is going to be very large, you know. So as by default, if we just consider this as a D by 2 and this also as D by 2 distance, so in this case this first capacitor will have its value, which is going to be C is equal to C dash, which is equal to A epsilon naught upon D by 2, which will make it 2C, correct है? तो ये C dash जो है वो हमको 2C के बराबर मिल जाएगा. In the same way here, this C dash, another value of capacitor here will also be 2 times of C. And since these two capacitors will come into series, so when 2C and 2C capacitors are connected in series, then in this case, the effective value of capacitance of series combination will actually be half of each of them. That means it will be simply C again, that which is going to be A epsilon naught upon D. So by inserting a plate, metal plate, thin metal plate between the two capacitors, the value of capacitor doesn't change. That means the value will be this A epsilon naught upon D only, which is already there in this option A here. Okay, T is 0, so we can just say that this C is going to be A epsilon naught upon D, no doubt. Chalo, next one. See, the energy stored in the condenser of capacity C, which has been raised to the potential V, is given by. ये तो simply memory based question है. Energy stored in the capacitor is given by half CV square. A capacity of capacitor is 48 microfarad. Okay, when it is charged from 0.1 coulomb to 0.5 coulomb, then the change in the energy stored in it is, yes, so when it will be at charge to 0.1 coulomb, the energy stored in it will be q square by 2c. ये फॉर्मूला हमारे पास होता है एनर्जी के लिए। ओके, तो जबकि यहाँ पे दो अलग अलग चार्जेस दिए हुए हैं, तो हमको दो अलग अलग टाइम्स एनर्जी निकालना पड़ेगा और उसका चेंज निकालने के लिए उनको सबट्रैक्ट करना पड़ेगा। तो you can just say that the final energy stored U2 minus initial energy stored, which is U1 here, which will be equal to Q2 square upon 2C minus Q1 square upon 2C. But as we can see that this 2C is going to be this common in the denominator, which can be taken once. And Q2 square minus Q1 square will be kept as it is in the numerator. So here Q1 and Q2 is already given. Q2 is given to be 0.5. So this 0.5 उसका square हमको करना है. Minus here it will be 0.1. उसका भी square करना है. That is to be divided by 2 times of capacity of the capacitor, which is going to be actually 48 microfarad. So it will be 48 and microfarad की वजह से यहाँ पे आएगा 10 raised to minus 6 here, right? And because of that, we can just solve this further. So delta U comes out to be actually 0.5 का square बनता है 0.25, right? And 0.1 का square बन गया 0.01, and that is to be divided by 2 times of 48, which actually happens to be, okay, we can write it as 4 into 24 into 10 raised to minus 6 kept as it is here, which will be actually 0.24 upon 4 into 24, and this 10 raised to minus 6 will just go in the numerator and becomes 10 raised to plus 6, so that here this 0.24 and 24 will just get cancelled, leaving behind 100 in the denominator, so that we can just get in the next step, that is 1 upon 4 into 100, and here it will be 10 raised to 6 kept as it is, which can also be written as 10 raised to 2 into 10 raised to 4, which makes it 10 raised to 4 upon 4, which can also be written as 100 into 100 upon 4, so that 100 can be cancelled with 4, leaving behind 25. So it will actually be 2500 as a final answer. So 2500 joules, matlab 2.5 into 10 raised to 3 joule, which is there in option number 2 here, which should be the correct one. Let us check. Yes. See the next question. The plates in the parallel plate capacitor are separated by distance d with air as a medium between the plates. In order to increase the capacity by 66%, a dielectric slab of dielectric constant 5 is introduced between the plates. What should be the thickness of dielectric slab? Okay, so let us take this question on our board. Yes, just read the question once again carefully. It tells us that a parallel plate capacitor, a parallel plate capacitor in my pass, which consists of parallel plates like this. This is the first plate here, and this should be the second plate here. Okay, and separated by distance d, मतलब यहाँ पे इस इन दोनों के बीच में जो डिस्टेंस है तो वो d इतना दिया हुआ है और वो एयर में है, मतलब इन दो प्लेट्स के बीच में यहाँ पे एयर है, ठीक है। So in order to increase the capacity by 66%, a dielectric slab of dielectric constant 5 is introduced in the between the plates. Yes, that means we have to introduce a dielectric constant in between these two plates. So let us consider that the thickness of this dielectric constant here or dielectric slab here is going to be T. Okay, तो अगर ये इस टाइप का डायरेक्ट्रिक स्लैब अगर हमने यहाँ पे इंट्रोड्यूस किया, yes, so this is the dielectric slab. ओके, तो ये डायरेक्ट्रिक स्लैब यहाँ पे हमने डाला है, जिसका थिकनेस हम मान लेते हैं, चलो T सपोज है, ये सपोज T है। ओके, तो अब देखो यहाँ पे डायरेक्ट्रिक है और बाहर में कुछ भी नहीं है, तो ऐसे कैपेसिटर का जो कैपेसिटेंस है वो निकालने के लिए एक सिंपल टेक्निक याद रखो, ठीक से एक फॉर्मूला याद रखो, कैपेसिटेंस ऑफ सच अ कैपेसिटर विल बी डिनोटेड और एक्सप्रेस्ड एज A epsilon naught अपॉन ये जो डायलेक्ट्रिक कांस्टेंट है उसका थिकनेस यहाँ पे आ जाएगा T अपॉन उसका खुद का डायलेक्ट्रिक कांस्टेंट के जो भी है, प्लस अभी दूसरा बचा हुआ जो पार्ट है उसका थिकनेस यहाँ पे आ जाएगा, जो कि यहाँ पे D माइनस T है, और उसके नीचे डिनोमिनेटर में उसका जो डायलेक्ट्रिक कांस्टेंट है जो कि एयर है, यहाँ पे एयर का डायलेक्ट्रिक कांस्टेंट 1 होता है, तो इसलिए यहाँ पे 1 आ जाएगा सिंपली। तो ये हमको समझना है अच्छी तरह से, समझा ठीक से? मतलब इन जनरल इफ सपोज दिस इज द कैपेसिटर and the space between these two plates of the capacitor is filled up by large number of dielectrics like this one, ये सपोज पहला वाला है, ये सपोज दूसरा वाला यहाँ पे डाल दिया है, इस तरह से ये दूसरा है, और उसके बाद सिर्फ सपोज इसका डायलेक्ट्रिक कांस्टेंट सपोज K2 है, okay, this is the K2 is the dielectric constant of this second. The first one is having the dielectric constant of K1 suppose, and suppose the third one is also there. ये तीसरा भी एक डायलेक्ट्रिक है जिसका डायलेक्ट्रिक कांस्टेंट यहाँ पे K3 है सपोज, ठीक है, K3, और इनका थिकनेस भी हमको पता है, सपोज ये जो फर्स्ट वाला है इस पे इसका थिकनेस सपोज T3 है, इस सेकेंड वाले का थिकनेस मान लेते हैं T2 है, और फर्स्ट वाले का जो थिकनेस है वो मान लेते हैं T1 है, ठीक है। तो ऐसे केस में इस ऐसे कैपेसिटर का जो कैपेसिटेंस है तो वो इस तरह से निकाला जा सकता है, A into epsilon naught will be kept constant as it is, and here in the denominator we can have this T1 divided by K1 plus T2 must be divided by K2 and T3 must be divided by K3 simply, and we can just get this as a final value of capacitance रेडीमेड। तो ये एक सिंपल रेडीमेड फॉर्मूला है इस टाइप का सिचुएशन सॉल्व करने के लिए। तो यहाँ पे हम देख रहे हैं कि द वन पार्ट T थिकनेस के अंदर डायरेक्ट्रिक कांस्टेंट 5 का एक डायरेक्ट्रिक स्लैब यहाँ पे डाला हुआ है, और ये बचा हुआ जो पार्ट है तो वहाँ पे तो एयर है, कुछ भी नहीं है, तो इसलिए फिर यहाँ पे एयर का डायरेक्ट्रिक कांस्टेंट हम 1 कंसिडर करते हैं, तो इसलिए यहाँ पे 1 आएगा और यहाँ पे K का वैल्यू 5 आएगा। तो इसलिए यहाँ पे जो डायरेक्ट्रिक स्लैब का जो थिकनेस है तो वो T आएगा यहाँ पे, which will be divided by this K, and here the remaining thickness here is going to be D minus T because the total thickness was D here, and इसमें से T का अगर वैल्यू कट कर दिया तो हमको बचेगा D minus T, and that will be kept here in the denominator, and which is divided by the dielectric constant of air, which is 1 actually. So if we just solve this further, then we can be able to get that C का जो वैल्यू है तो वो हमको मिल जाएगा आराम से, it will be actually A epsilon naught upon t upon 5 plus d minus t upon 1 simply. Okay, but this is the value of new capacitance. Okay, and the value of original capacitors is going to be given by the formula C is equal to, जब एयर फील्ड कैपेसिटर था तो उस समय उसका वैल्यू कितना था, तो वो रहता A एप्सिलॉन नॉट अपॉन D सिंपली. तो ये जो वैल्यू है वो ओरिजिनल कैपेसिटर का वैल्यू है. बट एज इट इज गिवन हियर दैट in order to increase the capacity by 66%, what does it mean? That the new capacitance here is going to be 66% greater than the original one. That means C dash is going to be C plus 66% of C. Okay, ये हमको दिया हुआ है, तो इसको सॉल्व करेंगे आगे, तो हमको मिलेगा C dash must be equal to C plus 0.66 times of C. If you just take this C common, then we can be able to get this as C dash is equal to C can be taken common and we'll be left with 1 plus 0.66 kept inside the bracket, which happens to be 1.66 actually. So C dash must be equal to 1.66 into C here. तो C dash और C के बीच में relationship हमको मिल गया, and this relationship requires the ratio of this C dash and C to be taken here. So if we just give this as equation number 1 and this as equation number 2, then we can just divide this equation 1 by 2 and get this C dash upon C left here, which will be actually equal to C dash upon C is going to be equal to, अभी देखो C dash का वैल्यू क्या है, ये पूरा है A epsilon naught, or we'll just take this slightly below so that confusion will not take place. So here we can see that this C dash, which is going to be actually A into epsilon naught, which is to be divided by T by 5 plus D minus T, okay, which is to be divided by this equation number 2, which is actually A epsilon naught upon D simply. But here A epsilon naught will just get cancelled, and what we are left with is, in the next step here, C dash upon C will become actually equal to D upon, ये जो D है वो ऊपर चला जाएगा, तो हमको मिलेगा D upon T by 5 plus D minus T as it is. But as we can know that this C dash upon C, so C dash upon C happens to be 1.66 actually. So if you just put it here, then we can get this 1.66, which is going to be equal to D upon, here it is T by 5 plus D minus T here. So that if you just multiply this, or 1.66 can be written as 4 by 3 actually. If you just write it in this fraction, so you can just write it as 5 by 3. So here it will be 5 by 3 and that is multiplied with this T by 5 ये टर्म हम उस तरफ लेके गए plus D minus T here, which is going to be equal to simply D here. So if we just take this 3 in that side, then we can be able to get this 5 into T by 5 plus D minus T is going to be equal to 3D here. So that in the next step, we can say it will be simply T plus 5D, okay, minus 5T, and that is going to be equal to 3D. So that this 3D can be brought in this side, and this 5T and T can be shifted to that side, so that we get this 5D minus 3D going to be equal to 5t minus t, so that 2d becomes equal to 4t, and hence t becomes actually equal to 2d by 4, and 2d by 4 means it should be d by 2 actually. So t becomes equal to d by 2 in this way, which is already there in the option 2 here, which should be the correct one. Let us check. It's the same thing is done here. Only the calculation part is not done carefully. So let us see the next question. Yes, in a parallel plate capacitor, the separation between the plates is 3 millimeter with air between them. Now 1 millimeter thick layer of material of dielectric constant 2 is introduced between the plates, due to which the capacity increases. In order to bring its capacity to the original value, the separation between the plates must be made. Okay, so let us take this question on our board once again. Okay, just read this question once again. In parallel plate capacitor, the separation between the plates is 3 millimeter. Okay. So once again, we have the parallel plate capacitor like this, and the separation between the plates is given to be 3 millimeter. Okay, तो ये जो distance है वो दिया हुआ है 3 millimeter. Okay. So now 1 millimeter thick layer of material of dielectric constant 2 is introduced between the plates, due to which the capacity will increase. Okay, so that means एक layer जो है 1 मिलीमीटर का एक layer हमने यहाँ पे इंट्रोड्यूस किया है. Suppose this is the layer of 1 millimeter. ओके, तो ये जो डिस्टेंस है ये 1 मिलीमीटर है. ओके, सो बचा हुआ डिस्टेंस फिर कितना होगा? 2 मिलीमीटर होगा जरूर, राइट? ओके, तो उसकी वजह से कैपेसिटी उसका बढ़ जाएगा, नो डाउट. बट नाउ in order to bring the capacity to the original value, the separation between the plates must be made. Okay, that means now we are going to move this plate in this direction here. तो ये जो प्लेट है तो ये हम एक्चुअली अभी इस डायरेक्शन में मूव करेंगे. Suppose that this is the hole as it is copied here. Okay, just forget about so that whole thing ओके, तो ये जो ओरिजिनल सिचुएशन ऐसा है, बट अभी हमको क्या करना है कि ये पूरा जो कैपेसिटेंस है वो फिर से अपना ओरिजिनल पोजीशन पे लाना है। तो उसके लिए हमको क्या करना पड़ेगा, इस प्लेट को हमको उठा के खींचना पड़ेगा। ये देखो, ये वाला जो प्लेट है इसको हम और आगे इस तरफ खींच लेंगे, और कितने डिस्टेंस से हमको इसको खींचना पड़ेगा। तो दैट मीन्स व्हाट शुड बी द in order to bring the capacity to its original value, the separation between the plates must be made। मतलब अभी इन दोनों प्लेट्स के बीच में जो डिस्टेंस है वो कितना हमको करना होगा, दैट इज यू हैव टू फाइंड इट आउट। ओके, मतलब यहाँ पे अभी ये 3 मिलीमीटर डिस्टेंस नहीं रहने वाला है उनके बीच में, जो कि अभी यहाँ पे it is going to get increased। let us take it as x in this case here। तो यहाँ पे वो x बन जाएगा, suppose that x is to be found out here in this case, what it should be, so that the capacity of this new capacitor becomes exactly same as original one। and again this distance is also not going to be 2 here in this case। यहाँ पे ये जो 2 हमने लिखा है यहाँ पे, वो भी 2 नहीं रहने वाला है, बल्कि वो अभी बढ़ने वाला है। we can just call it as this distance will actually be, ये जो डिस्टेंस है, बचा हुआ जो डिस्टेंस बनेगा वो एक्चुअली बनेगा x minus 1 here। you understand why? ये x minus 1 के बराबर बन जाएगा, क्योंकि एक मिलीमीटर तो हमने थिकनेस का डाल दिया ना स्लैब, तो इसलिए जो बचा हुआ डिस्टेंस है वो x minus 1 के बराबर रहने वाला है, जो कि हमको अब यहाँ पे कंसिडर करना है। ठीक है, अब देखो सबसे पहली बात क्या है ना, कि सबसे पहला कैपेसिटर कैसा था, उसके अंदर सिंपली ये 2 ही प्लेट्स थे, ये एक प्लेट और ये एक प्लेट, जिसका कैपेसिटेंस C रहा होगा। यहाँ पे कैपेसिटी एक इंक्रीज हो गया और यहाँ से और एक बार इंक्रीज हो गया, तो जबकि यहाँ पे पहला कैपेसिटेंस जो C इसका वैल्यू होगा, तो उसका वैल्यू कितना रहा होगा, तो हम बोल सकते हैं इट विल बी C इज इक्वल टू A into epsilon naught upon D, where D is going to be 3 millimeter here in this case। okay, so here we can say that this will be A into epsilon naught upon 3, but don't forget that this 3 is going to be in millimeter। okay, so this is the original capacity here, you can say, we can call it as equation number 1 here। okay, and now we want to find out the capacity of this capacitance C dash, which is the final one here। so C dash का जो capacity है, तो वो निकालने के लिए हमको फिर से वही फॉर्मूला यूज करना है जो कि हमने अभी भी देखा था। तो इट विल बी एक्चुअली A epsilon naught अपॉन, उसमें 2 पार्टीशन है, एक पार्टीशन जो है वो उसके अंदर डायरेक्ट्रिक स्लैब रखा हुआ है जिसका थिकनेस 1 मिलीमीटर का है, तो इसलिए फिर यहाँ पे हमको मिल जाएगा, और उसका भी डायरेक्ट्रिक कांस्टेंट 2 दिया हुआ है, तो इसलिए यहाँ पे हमको मिल जाएगा दिस 1 डिवाइडेड बाय 2 प्लस ये जो बचा हुआ डिस्टेंस है x minus 1 here, so that x minus 1 is filled with air actually, and that's why this x minus 1 is to be divided by 1 simply। but now this capacity C dash, we want this to be equal to the original capacity of the capacitor, which is C here। so if this is given as equation number 2, then we can just equate this C dash with C in this case, so as to get the value of x here। तो C dash equal to अगर C कर देंगे तो हमको मिलेगा क्या, तो इसमें देखो A epsilon naught upon 3 should be equal to A epsilon naught upon 1 by 2 minus x minus 1 simply। okay, sorry, plus x minus 1 simply, and just don't worry about this millimeter, because in both of these equations, this 3 also and this 1 also and x also is going to be in millimeter only, so it doesn't matter if we don't convert it into meter। so in this case here, if we just cancel out this A epsilon naught from both sides and just cross multiply it here, then we can get it as 1 by 2 plus x minus 1 should be equal to 3। okay, so which gives x going to be equal to 3 plus 1 minus half, which means x should be equal to actually 3 plus 1 is 4, or we can just say 3 plus half, because 1 minus half is half only, so that we can get this 3 plus half means 7 by 2 here, which is going to be 3.5, and that is again going to be in millimeter only. So the plate separation finally must be 3.5 millimeter, which is going to be there in the option number 3 here. Okay. Yes, let us check. The same thing is done here. The final capacity and original capacity is just equated, and we have expressed this d dash in terms of t. So we get this third option as a correct one, which is already there, 3.5 correct. Yes. So let us stop this lecture here, and just you can solve these all the further MCQs on your own. So we declare here that this chapter electrostatics has been finished at this point with JEE level. So बचे हुए जो MCQs है तो तुम solve करो खुद से, और कोई doubts है तो जरूर पूछो. Okay, so let us stop this lecture, and next time we'll just start the next chapter, that is current electricity. Okay. Yes. Thank you, all of you.